What if a building's load becomes more dangerous only after the building moves? Under compression, lateral displacement can create additional moment. Engineers call this a second-order effect. But there are two scales of amplification. P delta follows the sway of the frame within the member. Both allow axial force to generate additional bending. For an ideal elastic column, stability has a critical threshold. Euler showed that the critical load rises with bending stiffness, but falls with the square of effective length.
Real columns are not perfect mathematical lines. Initial imperfections, residual stresses, and structural restraint influence stability. That is why engineers do not.
In second-order analysis, axial force changes the structural response through geometric stiffness. The geometry is updated, equilibrium is checked again, and the solution advances until the result is not merely a larger number on a screen. If second-order effects become significant, engineers may revise member stiffness, restraint, or the lateral system before. Structural stability is not about preventing every movement. It is about undersurface structures or forces their occupants may never see. Structiqa.